Two containers are at the same temperature. The first contains gas with pressure P1, molecular mass M1, and RMS speed Vrms1. The second contains gas with pressure 2 times of the P1, molecular mass M2, and average speed V bar 2 equal to 2 times of the Vrms1. Find the mass ratio M1 to M2. It is given in the questions that the two gases in the containers, they have the same temperature. It means that the average kinetic energy per molecule for these two gases are the same. But it does not mean that the pressure of them are the same. In the first container, the pressure is P1, but in the second containers, the pressure is 2 times of the P1. For the M1 and M2, they are also not necessarily the same. That is why the question asks you to find what is the mass ratio M1 to M2. And to find this M1 and M2 ratio, the questions also provides the informations that the average speed V bar 2 for the second gas is the 2 times of the Vrms for the first gas. So now we want to find what is the ratios of the mass between these two types of the gas in the two containers. We start to solve the questions by taking notes that this is a key information. That means the average speed for the second gas is the 2 times of the Vrms for the first gas. So now we need to know what is the average speed formula. It is the square root of 8 over pi times RT over M, where the R is the gas constant, T is the temperature in Kelvin, and the capital M is the molar mass. For Vrms, we have this formula, which is the square root of 3 RT over M. Now we start from the equations given. That means the average speed for the second gas equal to 2 times of the Vrms for the first gas. Now we apply the formula for the average speed and the Vrms, and we will get these equations. But please take note that now, because we apply these two general formula into the two gases we investigate, that means now we need to add the subscripts for the mass M1 for the first gas and M2 for the second gas. The temperature for these two gases in two containers are the same. That's why there's no subscripts in this formula, in these equations. T and T is the same. To cancel the square root sign, now we take square both sides of the equality sign. That's why in the third line, we have the 4 here due to the square of these two. So we have 4. We cancel the RT and the RT and take this M1 over M2 as a subject. That means we move this M1 to the left hand side to get the M1 over M2. And this pi to the right hand side, this 8, we move it to the right. And then 4 over 8, we'll get 1/2. Multiply with 3. So we have 3 over 2 pi. So this is a ratio of the M1 over M2 equal to 3 over 2 pi. But this M1 over M2 is the molar mass. What we want to find is the small m1 over small m2, which is the ratios of the molecular masses between the two gases. So this is not the answer that we want. The molar mass can be related to the molecular mass, where the capital M1 is equal to Na times the small m1. Na is the number of Avogadro. This is the quantities of the molecules or the particles in the gas in 1 mole. Multiply with the mass for one molecule, then you will get the molar mass. Same thing happens for the second gas. So M2 can be substituted by Na times the M2. After cancel out the Avogadro numbers Na and Na, we will get the ratios of the M1 over M2 equal to 3 over 2 pi. So that means this is the answer that we want. This is the ratios of small m1 over m2 that we want to find. Three over 2 pi is equal to 4.7. 4.7 is larger than 1. That means the mass of the gas in the first container is larger than the mass of the gas in the second containers. Please take note that although the relationship between the pressure of the gases in two containers are given, where the pressure in the second gas is 2 times of the pressure in the first gas. But this information is not required for us to find the answer of this mass ratio.